Good afternoon. Thank you very much for this opportunity to participate in this conference. My apologies that I have to do it in a recorded manner because I'm currently in Oxford with my conference visit. And so today I'm going to present why Estonia needs its own chip industry. And I start with explaining what is a chip, but no, not about potato chips. So chip that we consider here is an integrated circuit that has been placed on a semiconductor die. So normally the material is silicon. And the first chip was created by Jack Kilby in 1959 when two transistors were actually placed on a single die. And on the same year, Robert Noyce developed a practical monolithic technology that is basically the same technology that is in use today. And today's chips don't have two, but the biggest ones have up to 2.6 trillion transistors. So it's an incredible increase. And chips are everywhere. So in all appliances, any kind of technological product or gadget we can imagine contains chips. And it's even hard to imagine products without chips. So how would, for example, a car look without chips, or a refrigerator? So here are some examples. So why Estonia needs its own chip industry? And why does a technology from 1959 matter still in 2024? So why should Estonia care about setting up its own chip industry when building a cutting-edge chip foundry costs hundreds of billions of euro? Wouldn't it be possible to continue building products from off-the-shelf components? So what Estonia can do or must do to become a player in high-tech? So these are the questions we are going to find out, and to find it out, let's take a look into the history of modern chips. So let's start from how chips are made, the design. So first, we start from an idea. We do the coding part, the simulation. We call it the front-end design. And then after being sure that the chip is actually functioning properly, we do synthesis to a structure, and then we actually do physical layout implementation. And finally, when this is ready, we tape out the mask and we send it to the factory, to the fab. And in Estonia, there are several companies where engineers can do the front-end design. But the back-end layout design, physical layout, tape out, it requires access to sophisticated CAD tools and technology libraries. And this is still not yet accessible to most of the companies. So how chips are made? So once a mask has been designed and submitted to the foundry, then inside the foundry, the chips are actually placed on a plate called a silicon wafer. And one wafer accommodates several chips. And the chips are manufactured by a photochemical process on the surface of that wafer. And later, separate individual chips will be sliced out from that wafer and placed into a package. So where are chips made? So mainly the chip production takes place in Asia, Far East, Taiwan, Japan, Korea, China, also in the US, mainly Intel, and in Europe there is really not so many foundries. So let's take a closer look. More than 20 years ago, the chip manufacturers used to be with their own foundries, so they used to have their own clean room on site. But due to skyrocketing costs, this task was outsourced to dedicated firms. And this was the emergence of both foundries and also the fabless chip companies. So talking of foundries, the biggest one, TSMC in Taiwan, is actually manufacturing more than half of the chips on that planet and more than 90% of the advanced processors. And 2/3 of the chip manufacturing services is actually from Taiwan. So Asia leads big, and US and especially EU, their share is marginal. So we can show it on that pie, and this is really small. But simultaneously with the emergence of foundries, we have moved to the fabless world. So nearly all chip manufacturers, nearly all chip companies are actually fabless. So the good example is NVIDIA, which became the biggest company and the most valuable company in the world this June. And also Apple is in the big three and is also a fabless chip producer. And other companies like ARM, AMD, Qualcomm, NXP, you name it, they are all fabless companies. The only exceptions here with cutting-edge foundries are Intel and Samsung. So how did we get to this situation? And why do we have a chip crisis and all these CHIPS Acts? So in early 2000s, as it was mentioned, there was a sort of globalization. So in order to save and to save on costs, the chip production was outsourced, and so mainly these foundries were established in Asia. And already then, in 2003, Senator Joseph Lieberman expressed concerns that this outsourcing and this losing of the chip manufacturing in the US and in the West is creating some security problems. But for a while this went on until several crises led to deglobalization. So in around 2015 to 2017, it became suddenly clear that the existing chip hardware microarchitectures, they are vulnerable. So basically, despite of all the crypto that we have implemented and developed, the secret keys are just easily to be read using these microarchitectural side channels. And attacks like Meltdown and Spectre became known and public. So people realized that it's not enough to protect yourself by software. So you need to actually take hardware and the chip design into account. Then right after it was a COVID crisis, which led to chip supply crisis. And then in 2022, the war in Ukraine started and tensions around Taiwan and Korea have also been increasing. So all this led to several strategic initiatives all around the globe. So for example, EU adopted its CHIPS Act in September 2023, where 43 billion euros were allocated for policy-driven investment until 2030. Also, US Chips and Science Act, 53 billion, Japan's Chip Act, $53 billion. Also in Taiwan, China, India, Pakistan, even Moldova, any country you name it or any region came up with its own initiative to support chips technology. So what is EU Chips Act about? So on one side, for strategic reasons, it's necessary to have a cutting-edge foundry in Europe to be able to access chips and from the fab. So currently there are plans of establishing a TSMC fab to Dresden, Germany. And this is for sure good news for Europe and also for Estonia. But keep in mind that this fab alone is not the full solution for the problem. The fab needs to produce something, and so Europe needs a fabless chip industry to support it. At this point of time, EU's market share in fabless is less than 1%, and among top 40 companies in the fabless domain, there are no European ones. So this is a big challenge, and Europe is going to put a lot of effort there to establish a healthy fabless sector. But in my opinion, and not only in my opinion, generally it is understood that the biggest challenge here is not the fab, and maybe it's not also the fabless sector, but the biggest challenge is the skilled workforce. So basically, EU needs rapidly 50,000 new chip engineers to run all this sector. And when we translate into Estonian scale, it means about 150 new chip engineers for the country in the near future. And then we may ask that if things are so challenging and so expensive and we need such high technology, can we really do it? Does Estonia really need to build its own chip capacity? And the short answer is yes, and definitely yes. So this is unavoidable. The main reason is the competitiveness aspect. So whenever we are planning our companies are launching some new products, technological products, then because of cost issues, size, weight constraints, and also performance parameters like speed, energy, power consumption, it is unavoidable to go for a chip technology and build custom application-specific integrated circuits. And then, of course, other items like national security and defense. So it's unthinkable to build security around a technology that is not relying on chip know-how. And we are in a good situation in Estonia in a sense that we have really many technology companies that already are starting to implement their own ASIC. So basically, for the reasons I mentioned above. And we also have some good examples of IP-based chip companies like Analog Design and Core HV. Okay, but what is holding us back then? So what are the obstacles and barriers? So Estonian electronics design companies are offering services of design services, but usually and generally they don't own their own IP and they don't produce chips, the majority of them. So why? Why don't they do that? So there is a high threshold in entering this chip business because of many reasons. So first of all, there is a lack of chip implementation competence. And there is also no access to the CAD software because of the extremely high license costs. So when we talk about this EDA CAD software, the yearly license could cost in around $1 million for one system. And also very high mask production costs and the lack of knowledge on the silicon technologies. So this sounds like a very high threshold. So how to get started with that? So we can also take a look at the semiconductor value chain. So it is extensive. So this is so wide that this cannot be handled by any single country or entity. And but Estonia can still contribute to many links in that chain. So basically, from the broad semiconductor value chain, we can actually be players in IP development, in developers of EDA tools. We have design companies. Also, other links or chain of the chain, like the backend design, producing end products, PCB design. This is something that Estonia is already doing, and how it is actually connected to this value chain. There are several types of companies in this value chain. So there are chip fabs like TSMC, Intel. There are integrated device manufacturers. These are companies that actually produce everything in-house, or more or less everything. So these are Samsung and Intel. And there are also fabless chip companies, IP providers. The famous ones, the biggest ones, are NVIDIA, Apple, AMD, and ARM. So these are companies that own IP, that produce chips, but they don't have a foundry. And then we have design houses, which mainly do subcontracting work. So actually, world is full of design houses. So there's no very big thing about this. So and these are small enterprises that actually at this point lack their own IP, but these could be transferred to the fabless sector. And finally, we have also outsourced assembly and test, and Estonian companies may enter that field also. So, but the case for Estonia is that for sure, for size reasons, we can never have chip fabs or integrated device manufacturers. And that's okay. But what we should do is that we should support the transition from design houses that do subcontracting into fabless chip companies. It means companies with their own IP. And this transition is not simple, easy, but it costs and it's very risky, so it needs to be supported. Luckily, there are some good news for Estonia. So just 1 week ago, a proposal was submitted to Brussels about establishing a chip competence center to Estonia. So the center is called KEEP, which means chip in Estonian, and it stands for Knowledge Transfer of Innovative ICs and Processes. The total budget of this center is 2.4 million, and it runs for 4 years. So funding is shared by the Estonian Ministry of Economics and Communications and the CHIPS.eu organization. The partners include Enterprise Estonia, Metrocert, and the Estonian Electronics Industries Association. With the rest of the ecosystem, the Estonian universities, TalTech and Tartu, as well as a wider ecosystem with companies, RTOs, and the government organizations are also included. And this center offers also consultation and services to partner centers within the European network. So the main focus areas here in Estonia are hardware security, test and safety, and functional verification, which have traditionally been the strong areas in the chip research in Estonia. And the support activities of KEEP, they include facilitating access to the design platform and to pilot lines. So design platform is a CAD tools, and the pilot lines is actually the silicon technology. We are also supporting interested stakeholders, mainly startup companies and SMEs, in developing semiconductor solutions. We are providing access to training on skills, and this is mainly operated and completed conducted by the TalTech University. We facilitate access to other European network competence centers. So each EU country will have its own chip competence center. And of course, we promote then the other opportunities like the CHIPS Fund, finding investment. And we promote the chip domain. We raise awareness. We present success stories so that this area will have a stronger impact within the country and within Europe. So Estonia has been pretty successful in chip research in Europe, actually. So we have started in 1990s. There was a chip lab built by academician Raimond Ubar, and the first microchip one micron technology crypto chip that was created in 1997. And over the last 8 years, we have been really active in taping out new chip projects. So the university does around 1-2 new chip projects annually. Okay, there's a typo. So over the last 8 years, we have done eight ASIC projects, and we are relying on programs like Europractice and Siemens. Currently, starting from September, there are two major research actions that are ongoing, where Taltech is actually the leading partner. And this is one of these examples is the TaiChip project, which is about reliable and efficient AI chip design. And the budget of this project is 1.7 million euros, and the partners include Manchester, ETH Zurich, École Centrale Lyon, and IHP Germany. And there's another activity going on called Tiramisu, which is a training network. So it's about recruiting 17 PhD students on the topic of reliable and efficient chip design for edge AI. And this project is also led by Taltech, Professor Maxim Yanichin, and the budget is 4.3 million euros, with partners including IMEC, Fraunhofer, TU Delft, Infineon, etc. So, thank you. And as Estonians say, keep kotti.
And I thought Estonians actually say keep under your skin. There are a few people who have done that step. Jaan, we have you on the screen live, ladies and gentlemen. This is for you to ask questions from him. Do we have a question from the audience? I don't, again, see any in Slido. Well, let me start then. Jaan, where do you see the Estonian chip industry in 5 years?
Well, I see that in 4 years, let's say, we get some new startups that will start in chip production. So I think there will be something like 5 to 10 new companies, new players, and I don't know how many of these companies will be successful or let's say grow big or become unicorns or something. But I think that there will be some new chip companies definitely, and this KEEP center will support that. And also some of the existing companies may move fabless. So there is at least a lot of interest. So definitely something will come out. So
the business prospect and the business model of the Estonian chip industry, should it focus on fabless, design house? Where do you see the right business in Estonia?
Well, as I said, I mean, design houses are all over. So this is not a good model. It's not really scaling. I mean, it's the only way is to have your own IP, have your own chips. So this way you can actually it's like you can license your technology and so on. I mean, if you're just selling your work hours, I mean, this doesn't scale.
Believe me, I know. Yeah, it's very difficult to scale myself. I've been counting on AI to replicate and moderate 3 conferences at the same time. So far, it hasn't happened. Dear friends, do you have any questions? Oh, we have a question over here. A microphone is heading your way.
Thank you so much for your presentation on this extremely important topic. But you mentioned about some support and the CHIP Acts in different countries and regions. And my question is, how you think? Is it enough support to bring some important results in your future? And if we get some additional support like money, could it increase our progress in this area, or additional money will be not so necessary because problem is in abilities, opportunities, specialists, and maybe with support is enough or not? Thank you so much.
Thank you. Very, very good question. I think there is enough money actually. And I think it's important, of course, that Estonia is willing to invest into that. That's super important. But I think you already answered the question. So in the second part of your question, so really the shortage of skilled workforce and training is the key. So this is the hardest challenge for sure. Money alone will not solve it. I mean, we have to change and improve our education and research as well to support training of these experts.
And one last question: could Europe be as big as Taiwan in chip industry? The EU is putting money in, but will we inevitably lag behind Taiwan?
No, I think it's our only opportunity. I give you an example. So a leading European car manufacturer is developing its autonomous car division, and they include chips from US chip makers for AI. And these chip companies, they are saying that, oh, that's very good, that's very nice, but we would like to have 40% of your revenues. So, I mean, Europe doesn't have an option. We have to go there.
Thank you very much, Jaan. An applause, ladies and gentlemen.
Thank you.